like the supervised version. So what is say your advantage? You said using weak localization is better, and why is that?
Yeah, the main reason why I say it is good is that we don't need semantically segmented annotation data. For example, if you want to use fully supervised semantic segmentation, you have to provide the data for all of your images. For example, if you have 100,000 images, you have to provide semantic annotation for all those data. But in the case of weak localization, you only have a small amount of annotation, which is bounding box annotation. Then providing bounding box annotation is simple compared to the semantic segmentation. And also, you don't have to like annotate all of your images. You annotate only a few of them, and your network will get advantage from those small amount of annotated data.
Can we say that your work is semi-supervised?
Yes, it's also we can also say that like it is not unsupervised. Yes, of course, it is supervised with a small amount of data. Yeah.
Mm-hmm.
Yeah.
Okay. From the audience, any questions? Questions in this kind of settings are usually good for the researcher because it helps them to improve their work in the future. So I encourage the audience to ask questions. Okay, if you don't have any questions, thank you, Dagaga, for your nice presentation. And then we should go to the next presenter, who she's Albetel Hayezode, and she'll be presenting her work on machine learning-based stroke segmentation and classification from the CT scan. And it's a survey of work in that area. Albetel, your presentation was there, but then it disappeared.
Yeah, can you hear me now?
Yes.
Okay, yeah, we can see it now.
Okay, good morning, everyone.
Wait. Before you move on, we only see not we don't see the full slide. We just see the slide, the PowerPoint window.
Oh, okay. Let me try it once again. What about now?
Wait, it's coming.
Okay.
Have you shared?
My screen. Okay, can I once again?
Does anyone see the shared screen? I can't see it.
No.
البت hello البت.
What about you?
Yes, perfect now. It works now.
Okay. So shall I start?
Yes. Okay. Yes, you can start now.
Okay, good morning. Good morning, everyone. My name is Elvetil Taye, and I'm going to present for you on a survey study that was done on machine learning-based stroke segmentation and classification paper review. So, as we all know, brain stroke is a disease or a condition which occurs when there is a burst of vessels inside the brain. And this disease is a life-threatening condition which might cause days or permanent disability. And basically, it is classified into two type of strokes. So the first one is ischemic and the other is hemorrhagic type. And it is mostly diagnosed by using the CT scan imaging modality. So according to the World Stroke Organization's report in 2019, 80% of the stroke types which affect a human being are the ischemic type of stroke. And among the stroke, 63% of the cases occur in people that are younger than 70 years old, and 89% of the disease might result in days and disability in low and middle income countries. And it is reported as the second leading cause of days and the third leading of disability or leading cause of disability throughout the world. Nowadays, we all know that machine learning and deep learning techniques are being applied to the medical sector. And this will have a great use or support in providing personalized clinical cares and disease. It will also help in disease detection and disease type and subtype classification and the like. So the main advantage of this application of machine learning to the medical sector will help in decreasing the workload of physicians, reducing the misdiagnosis rate that might happen due to subjectivity error and other. This review is the type of, to identify the type of machine learning and deep learning frameworks that are commonly being used on CT scan image segmentation and classification tasks, and to identify the existing machine learning techniques efficiency, and to identify the publicly existing data sets which can be used to develop machine learning models, and also to answer the to identify the limitations and the challenges that are currently existing on machine learning and deep learning based stroke segmentation and classification tasks. So we have gone through some steps to go through the review. So the first thing we have done was to identify the keywords so that we can select the potential papers that will help us to answer all the questions that we have listed previously. So the next step after identifying the keywords was to select potential journals which are Scopus indexed, and to define the time frame that we shall consider for the papers, or the publication year was in between 2018 and 2023. Then we defined some inclusion and exclusion criteria so that we can select only the relevant papers from all the published papers. So coming to the inclusion and exclusion criteria that we have used, it includes the first one is the papers must focus on the deep learning and machine learning based approach to do CT scan image segmentation and classification of brain stroke disease, and the other inclusion criteria was the time frame of the publication year, and the other is the paper must at least hold one of the type of strokes, and we have also considered the journals, whether they are Scopus indexed or not. And coming to the exclusion criteria, we only considered studies that were reported in English language, and we excluded duplication of publications, and we excluded case study papers. So from the review, we have found, based on those inclusion and exclusion criteria, we selected the most relevant papers, and from those relevant papers, we have identified that only basic 5 data sets were available, which will help to do machine learning, to develop machine learning models for brain stroke, either segmentation and classification task. So as you can see from the slide, some of the data sets hold this mask, and the others don't have included. They didn't include the mask of the image for the slices. And the other thing that we have found from the review was we have identified the potential artifacts that can affect CT scan images or brain CT scan images. So this includes motion artifacts, ring artifacts, Gaussian noise, beam hardening, and scattering. And these noises have the potential to hinder or affect the brain stroke image to the point where they cannot be used for diagnosis purpose. So we have also identified the denoising approach that some of the researchers used to avoid those noises. So this includes iterative reconstruction technique to remove the beam hardening artifact, and the other is median filtering and Gaussian filtering, adaptive filtering techniques to remove or reduce noises and to enhance the image quality. And the other is calibration. They have used that to remove ring artifacts and the like. So as we have said, we have considered both studies that focused on segmentation as well as classification of brain stroke disease from CT scan images. So as we know, review, both classical machine learning and deep learning approaches were found to be used. So from the classical machine